Also, wir haben Graphical System Design vorgestellt, wir haben die Hardware-Plattform vorgestellt. Jetzt machen wir wieder den Übergang. Was ist Graphical System Design ohne LabVIEW? Und I'd like to get you back on the stage, Norma, and talk about LabVIEW, how LabVIEW fits in the graphical system design framework.
Okay, so before we look at LabVIEW 2011 today, let's take a look at what's in store for LabVIEW for the next 25 years.
So I guess we're going to see a film.
Yes, I believe so.
Very fancy stuff.
Yes.
So, but we are still here today and now, and let's talk about LabVIEW as it is today and the new version of LabVIEW. Maybe you can give us an insight into how the new version looks like.
Sure, Ramon. Well, in my career at National Instruments, I've launched many different versions of LabVIEW, and I can say that hands down, this is the most stable, reliable release that we've ever created. Now, I know that every one of us needs reliable software platforms to work with, but as more of you are taking LabVIEW into mission-critical, production-oriented types of applications, our tools need to be able to increase performance and reliability accordingly. So behind me, you're going to look at a chart that shows the inflow of new bugs that are introduced prior to a major software release. Now, the first three curves show those last few releases of LabVIEW, where you see the typical curve of when we introduce new features into the software product, you start testing and debugging in order to drive those bugs discovered down. Let's take a look at the bottom curve, which shows LabVIEW 2011. And you can see that despite massively increased testing and more rigorous testing throughout that process, we actually experienced a 30% decrease in the number of new bugs found.
Okay, these are our internal metrics, and we are happy about it, but what do our customers think of it?
You're right. Internal metrics tell us one thing, but the proof is how our users are experiencing the product. And based on these quotes behind me, I can confidently say that LabVIEW 2011 is a reliable release.
Wonderful. So we have a very safe environment. Now, what about the features that are running in the safe environment? Can you just enumerate a couple of features?
Sure, sure. We have a few minutes to talk about just a few of the hundreds of new features that we introduced in LabVIEW 2011 to increase the productivity and accelerate development for every LabVIEW developer. So I'm going to go ahead and talk a little bit about some of the new user interface VIs. You might have noticed them throughout the demos this morning. Another piece that we introduced was new multi-threading VIs in order to take advantage of more high-performance measurements and control using multi-core processors. And you might want to check out whether you've seen one of the idea exchange demos that, or one of the idea exchange features, excuse me. Trying to find my VI. I think it's got.
We introduced idea exchange a couple of years ago with LabVIEW 2009, and we received a lot of good feedback also from our region, and I think it's a great place to get your feature on the list and get it on the next version of LabVIEW.
So in Idea Exchange, we implemented 13 new features for LabVIEW 2011, one of which was to be able to easily check whether your plots are visible or not visible directly from the front panel, so it saves a lot of time. Another was to implement glyphs over your type defs so that you can easily identify them and create them, which were both Idea Exchange features. Also, when you create sub-VIs from selection, it now automatically selects the correct standard connector pane. It allows you to see the connector pane with your icon at the same time the entire time your VI is there, so that it's easily visible, another Idea Exchange feature. And the error wires that come in the left and right terminal blocks are automatically wired for you. And your front panel is automatically laid out with the correct labels on that front panel, so it saves you a tremendous amount of time. And finally, one of my favorite features is how often are you putting down a while loop on your block diagram? Well, now you can wire the error wire, which, of course, you always want to stop your while loop if there's an error detected. You can take your error wire and wire it directly into the Boolean terminal of that diagram. So I'm super excited by the hundreds of features in LabVIEW. And
your description is much better than the actual
it's
program.
So irritating. I'm sorry. Okay, so also in the LabVIEW add-ons ecosystem that you can use, because of course it's not just what's in LabVIEW, but it's also what you and other partners of ours are building to be a part of that LabVIEW ecosystem. Now you can, from within the product itself, review, install, and download tools directly from the LabVIEW Tools Network. In addition, LabVIEW 2011 also runs .NET assemblies that were written in .NET 4.0, and you can add that to all of the other IP that you can normally integrate into LabVIEW, like DLLs, .m files, IP from anywhere to help boost your development.
I just saw someone installing it at the back, so it's running, but we'll show it later on. We'll do the proof once we are over, otherwise we'll run out of time. So let's talk about the next steps in LabVIEW. Okay. Where we are heading towards, and in the fancy video that we saw, let's get to that, because I think everybody's really excited to see that live. So where are we with LabVIEW in terms of the future?
In order to help me talk about LabVIEW for the future, I'd like to welcome one of our key strategic technology partners, Xilinx. So I'd like to introduce Mr. Giles Peckham. He is the EMEA Marketing Director for Xilinx.
Hello, Giles. Welcome to Germany.
Morning, Roman. Thank you.
What's new with Xilinx?
Good question. Good question. Morning, everybody. It's good to see National Instruments addressing the needs of so many different markets that both National Instruments and Xilinx jointly serve. And I see many applications which we together are responsible for. And in those applications, we're finding many new challenges. So, for instance, if we look at the next screen.
It is at the back. It's just slightly delayed.
So in automotive driver assistance, for instance, there are new and emerging products which are enabling us to see the road signs well ahead, to avoid collisions with other cars, and to help keep us safe on the roads. Also in intelligent video surveillance, we have security systems which enable us to avoid many of the issues which the world is experiencing today. And in industrial control, we're building, or helping to build, systems that will allow robots to have the manual dexterity of human beings. And I see some of those applications here in the exhibition hall at the event. Now, I could go on and list many other applications where the demands of those systems go beyond the capabilities of today's embedded systems. So what we need to serve those markets is a way of enabling those applications to reach the high-performance video processing needs, plus the high-speed, real-time data processing, and all at the same time minimizing both the cost and the power consumption. These are two driving factors in all of those applications. So in order to address that market, what we needed to create was a device with the software programmability of an embedded processor, together with the hardware flexibility of an FPGA, and the single chip integration that's capable with today's 28-nanometer technology, giving the benefits of a full integration system on chip.
So I'm sure you have a new chip with you, and I'm sure that you'll introduce a new architecture.
Yes, we are, absolutely. So we've been working together with National Instruments on this new device for a little while now. We've called this new device Zynq. The Zynq 7000 is the first in a new class of product which we've dubbed the Extensible Processing Platform. And if we take a look under the lid of the Zynq product, we can see what's actually inside it. So first, on the top left-hand corner, we see a completely independent, hardwired ARM Cortex-A9 dual-core based processor system. This processor system comprises dedicated L1 and L2 cache, memory controllers, peripherals, everything you would expect to find in a processor system. And that is completely independent of the programmable logic which also exists inside that device. That processor system will run at up to 800 megahertz. That's the kind of performance levels which you'd see in standard processors. And it is the most advanced ARM-based system that you can buy in silicon today. So it's completely independent, but in addition, we have on that chip the programmable logic, which you see in yellow down the right-hand side and across the bottom. That is our 28 nanometer programmable logic that we're also rolling out in our 7 series FPGAs today. And that allows you to build additional functionality in logic. It allows you to build custom accelerators and custom peripherals into your device. And you link to that programmable logic through more than 3,000 high-performance interfaces using the AXI4 interface, the standard ARM AXI4 interface. Now those 3,000 connections give you enormous bandwidth and very low latency, which is simply not possible in a two-chip solution. So that gives you the kind of capability that we think you need to address the demands we were looking at before. Plus, obviously, the capability to interface to the rest of your board using a very flexible external I/O. And that can include, for instance, high-speed SerDes interfaces at up to 12.5 gigabits per second, allowing you to do PCI Express and PCI Express Gen 2, plus a number of other interfaces, DDR3, LVDS, and also, of course, mixed signal interfaces. We have dual A to D converter, multi-channel capability on the same device. So quite a comprehensive.
Right. So for a layman's language, we have the FPGA as the heart of the system. We have ARM-based capabilities, and then we have I/O. So Norma, I think this is the LabVIEW chip, right? Can I use that term?
I think that would be great to call it the LabVIEW chip.
Okay, Giles,
great.
Maybe a little hint. I think we have together on the 15th of November a virtual conference where we are going into some details of the Zynq, and you will get an invitation for it. So I think let's take it to that event. Xilinx is doing this event with some of the partners, including National Instruments, and there we'll talk about the capabilities of this new Zynq processor and also our capabilities or our vision.
That's right, Roman. In fact, we're going to look inside the design flow, both hardware and software, for this device. And it'll be National Instruments, Xilinx, ARM, and one or two other partners. So November 15th, we'll tell you about it in some emails before the time. Thank you, Roman.
Wonderful. Thank you, Giles.
Oh.
Thank you.
I have to speed up a bit.
Oh, it's all right. Thank you.
Okay.
So fast.